confidence user interface programming, which is very specifically not correct user interface programming, because correct is significantly more expensive and I think often not worth it. And so what I'm going to explore is what do I mean by confidence and how do you get confidence?
Like what is required to achieve confidence? And helpfully, somebody wrote a think piece on Medium recently, which summarized some of my thoughts, so I can just say, hey, what this person said. So hopefully some of you might have seen this. It did the rounds a few weeks ago. So software development at 1 hertz. And the general theme of this article is about getting a feedback cycle that is approximately 1 second long, or less, ideally. So some people say like, oh yeah, a 20-second build, and they're like, yeah, that's fine. But like 20 seconds is a gap. Like 1 second isn't quite long enough to be a gap. Like you hit a thing, you get feedback in a second. It doesn't feel like a pause. Obviously you notice it, but it's not long enough for your mind to wander. It's not long enough for you to do something else. And so what I want to talk about today is how do we get feedback within 1 hertz while doing front-end development. So I mostly work in the world of JavaScript. And as I'm sure many of you know, there's lots of existing. I forgot to check my font size. Okay, so we have a bunch of existing tools that are in fairly common use in JavaScript for getting like fast feedback. And hopefully some of you are using these today, although not everyone is, so I'm just going to mention a couple of the more simple ones. So one of the common tools you can get is a linter. So I have omitted a semicolon there, which is a very sort of fatal error in JavaScript. It's important to always type your semicolons. And so I've set up some software to tell me as I type, hey, make sure you put those semicolons in, and I get very quick feedback. So you should be able to see, as I remove that semicolon, I get a little like red box there, and that's useful. It also tells me about actual useful errors. So if I say, for instance, make up a variable that doesn't exist, it will tell me about this. And this is very simple, so I just set up a linter, integrate with my editor, and now I'm getting quick feedback about a certain type of error. I've also got tests, so this code here is my tests. If I were to say change a line in my test, then I should get a failure. And what you'll notice is over on the left, I get some failures. And if you were watching closely, you'd have seen in your peripheral vision up in the top corner, there's a little flash of color, which is whether or not my test passed or failed. Now this particular test suite runs in around sort of a few milliseconds, so I get extremely quick feedback about whether or not my previous test run was successful. And on the whole, any sort of project I'm working on, I try and keep the test suite to take around about 1 second, so that I can run my entire test suite every time I make a change, and I can get that feedback. And there are some tools that can take advantage of your dependency graph in your system, so it knows that when I make a change, only these tests could possibly be affected, assuming we're not leaking some global state somewhere, and that can manage to give us a much larger test suite, but still give us that 1 second of feedback. And in JavaScript now, we can also get things like type checkers, Flow or TypeScript, or even compile to JavaScript languages will give us those abilities. And again, this is all about giving us feedback quickly into a code. And these are things which exist today and are in fairly common use, and hopefully most of you have at least heard of these things. But what I want to talk about for the rest of the talk is something a bit different. So the 3 things I've shown you so far, or talked about, linting, unit tests, and type checking. How useful is that when building a user interface? And what do I mean by user interface? I mean like a rich, interactive application. So here is my rich interactive application that I built for today. So this is, it's a multi-page app that you interact with. It's a single-page JavaScript app, rich internet application. This particular one, oh God, we don't use that term anymore. This particular one doesn't talk to a server, but often these things do. So I've written a bunch of applications like this, and I've used linting, and I've used unit tests, and I've written components with heavy unit tests on them. But I still always felt the need to go and open up the app and look at my component to make sure it looks right and actually behaves correctly. Like I'm not getting enough confidence from my tests or my types or my linting to allow me to say I'm going to make a change and I know this works. I don't need to go like view the code in the browser. Now, if I'm working with, say, an API, for example, often I can get enough confidence from just the test that, yes, this will run correctly because the input-output is data structures. But the input-output for something like this is much more complicated. So what I want to talk about today is an approach, which I think works reasonably well for getting effective feedback when you're building a user interface like this. But before I go into that, I just want to take a brief detour into sort of an area in JavaScript land called hot module reloading. Now in this particular system, this is powered by a tool called Webpack, and there's a few other ways of doing this. So Webpack itself is just a really flexible compiler toolkit that can do anything. It's often used in practice as a JavaScript module bundler. But anyway, so this should feel familiar to you, what I'm about to do. So I have my application. I'm on page 1, so I get to pick a character. Anyone want to shout out a choice? Barry Bear, good choice. Okay, so we've got Barry Bear. So we've chosen Barry Bear, and now the second choice is we get to choose like a weapon that Barry Bear gets to wear. So someone want to pick a weapon? Beer. Okay, the beer is the choice. Okay, there you go. So as you can clearly, okay, that doesn't look very good, does it? Okay, hang on. So I load up my web inspector, and I've got, so this row selected, and there's a color here. So let's try, should we say like 50%? Is that better? It's a bit, I don't know, it's a bit garish for my taste. I'm going to try 70, 80, 90. So this very clearly passes our 1 Hertz test. So I'm interacting with the page and I'm seeing feedback immediately. So I think 80 is actually the nicest of those. So there we go. So now we've got a nice sort of pale orange. So that's good. But I've not actually made that change. I've just interacted with the page. So I've got to go actually make it. So here we go. This is my code. So let's make that 80% and then hit save. And then I need to make sure that worked. So I refresh the page. Okay, and I'm going to put the bear and then the beer. Okay, yeah, so good. So that's looking right. And what you might have noticed was that failed the 1 Hertz test. So when I made the change in my editor, it took me slightly more than a second to get back to this because it was on the second page, which was mildly annoying. But anyway, that wasn't terrible. That was okay. Like, I managed to figure out what change I wanted pretty quickly, and then applying it, I just had to double check it actually applied correctly. So that's fine. Anyway, so I'll pick the beer and I'll move on to the next step. So this is actually a betting game. So I've got 100 credits up here, and I get to enter my stake. So I'm going to bet 30 credits, and I'm going to begin my fight. So I get a little animated fight, and I lost 30 credits. And that message feels a little bit impersonal, actually. So let's make the message a bit nicer. So let's say, sorry, you lost N credits. So I'm using React over here on the right, but it basically just looks like HTML at this point. So anyway, so I hit save, and then I hit refresh, and then I have the bear, and I've got the beer, and I go next, and into my stake, and I begin my fight. And there we go, you can see the message. So that's kind of annoying. So hopefully this is familiar to you. This is how we all build web pages every day. You make a change, you reload the page, you click a bunch of stuff to get back into the state you're in, and if you're lucky, you do get back into the state you're in. Or in my case, if I'm unlucky, or if I've done something to rig it, so it always does this, then you get a different message. Okay, so what's the solution? So the solution is something called hot module reloading. So if I reload this page now in hot module mode, what I've done is I've enabled a connection live to the server, and when the server recompiles the JavaScript, it will send like a patch down to the client which gets applied directly. So we can see that here with the CSS. So this, in this respect, is similar to like CSS live reload. So I hit save on my editor on the side, and then it immediately changes the code on my left. So I can see, okay, that's got me back down under that 1 Hertz barrier, but I'm now actually editing my actual code in my actual editor using whatever tools I feel like, and it's just getting applied. So that's pretty good. So we go over here, and then we have our fight. We begin our fight. And then, okay, we did get the lost message this time, but actually I want to see what the other message is like, or I want to change this message. So now I'm just going to modify my JavaScript, and that's going to take effect immediately. So I can do whatever I want. And actually I say, well, okay, I want to say the win message, so I could play around with the state and make it react differently. So there's some tools in React where I can change the state. Or actually, I've got the code right here, so I can just put like true or at the start of this. And then actually I'm going to see both messages at once with this change. Oh no, I'm not, because of operator precedence. There we go. Yeah, I can see both messages at once, so let's make that a bit nicer as well. Hit save, yeah, okay, that's fine, and then make sure I put my code back so I don't end up with both messages on the page. So that's kind of nice, and actually what I might want to do is like rerun the fight animation, so I've helpfully just dropped something useful onto the window object. So what I've done here now is I've sort of changed my code and written it in a way that's a little bit different so that I can interact with it more directly onto the page. So I'm not just using a system that allows me to make changes easily. I'm then saying, oh, actually, now that I've got this system, I want to make my code write my code slightly differently so I can take advantage of these changes. So that's hot module reloading, and that dramatically reduces this feedback cycle, hopefully down to under this sort of magic 1 Hertz barrier that someone on Medium decided was a thing. So that's good. This is nice, and that works. So hot module reloading. So one thing I like to say is it turns this into like almost a conversation with my applications. I'm saying, oh, what if I did this? What if I did this? And I'm trying it out, and I'm getting that feedback really, really quickly, and that's great. But this isn't necessarily a panacea. It does leave us with some problems. So one thing you could spot here when I said, okay, I can either show you, normally it would either show you the win message or the lose message at any one time. And if I wanted to show both, I had to like modify the code. And this is basically because a given user interface component has a number of possible states it can be in, possibly a large number of possible states it can be in. And in my actual application, generally, there is only one. So my application is running, and it's in one state at a time. So if as soon as I have a bit of conditional logic in my code, then I need some way to exercise it in both scenarios. And the way I do that generally is by clicking something or typing something. But if we think about when we're not working in user interface code, how do we approach this? If we've got a bunch of functions, then we write unit tests. And the unit tests will exercise our function under a number of different scenarios. Or we could even get a bit fancier and do property-based testing and generate the scenarios. Or if we're feeling particularly fancy, we can prove things, but I'm not necessarily sure what you would prove about, does this page look nice? That's a difficult property to assert on. And I'm still not convinced it does. This is the extent of my design skills are large font size emoji. Cool. So, what's next? A couple of years ago, I saw a talk by a guy called Bruce Howman. So this is, if you've ever done any Clojure or ClojureScript work, this is the author of Figwheel, which is the hot code reloading tool that works with ClojureScript. And he did talk at Strangeloop, I think it was actually just over a year ago, entitled Dev Cards. So basically, Dev Cards is a ClojureScript library that sort of builds on these concepts that we had around hot code reloading and around sort of having user interface components and sort of embedding them into the page and sort of giving us a way to interact with them. And I really liked this, and this was great. And I was like, oh, brilliant, I want to use this. But I don't do ClojureScript in my day job, unfortunately. And although maybe some people in this audience do, so I couldn't just switch over to ClojureScript. But I thought, well, actually, this idea seems pretty relatively universal. Like, can I just port it to JavaScript? And the general answer is yes. Yes, I could just port it to JavaScript. So this is the same thing, but ported to JavaScript. So this builds on the things we've seen so far. So these ideas of like iterative unit testing type approaches, this idea of components. And now what we've got is the Devboard. So Devboard is really just a bunch of functions and conventions that give you an easy way to build pages that will give you for you to give yourself better feedback. So I've been working on this for a little over a year now, or a little under a year, and I'm still struggling to find a shorter sentence that says that same thing. But this is where I am. So a 45-minute talk is the approach at this point. So what I've got here is this function define card, and it has a bunch of properties and things. So I can give it a title, which you can see appears over here. So this is the title, and as I change it, so I've got the hot reloading stuff enabled. So when I hit save on the side, then I should get a rebuild, and I get an update there. And that took slightly longer than I wanted to, but that's fine. It's still close to a second. This second argument here is actually Markdown, so I can type a bit of Markdown in here. That's not valid Markdown, but that is. And I get like a sort of nicely rendered bit of text. There's a horizontal line there you can't see because of contrast reasons. But yeah, I can type things. I hope. Yeah, I can type things. And so the idea is this gives you like an almost sort of literate programming type interactive loop where you can put things over here and they appear on this side. So this in itself isn't particularly interesting. The interesting thing is actually the third argument. So the third argument is the body of the card. So generally I've got a title, I've got some documentation, and then I've got a body. And the body is effectively extremely polymorphic, so I can put anything in there and the card attempts to render it in a useful way. So for instance, if I give it a number, it says, hey, here's the number. If I give it like a data structure, then it will give me a sort of a pretty printed version of that data structure that I can see. If I give it a date, it will say, okay, here's what a date looks like. And these are pretty boring examples so far. So if I wanted to do something interesting, so if I gave it a regular expression, then it will give me an interactive regular expression editor type thing that will tell me whether or not something matches. So this is just a sort of result of me thinking, okay, given a particular type, like what is this? What is a useful thing I can give you on a page to give you feedback? But the most useful thing you can do with these things is to put a React component in there. So here I'm just going to type a little bit of React code, and that will render. And this also works with custom components, which is when it starts to get actually useful. So the idea is, what I'm going to do is sort of walk you through the experience of trying to build a component using a system like this. So the component I've decided to build today is going to be a thermometer. So I've got a second card here, just down here. So this is my card. So if I just focus it, there we go. So just this card only. This is going to be a thermometer. In fact, it currently is a thermometer. It's just not a very interesting one. And it's telling you it's quite warm in here, which it is. So what we want to do to make this more like a thermometer is sort of visualize this temperature. So we've got a number, and as well as a number, we're going to get a visual representation of our thermometer thing. Yep, that's right. So we can put the number below, and then above the number, let's put something slightly more interesting. So let's have a background of red, and for now, let's just hard code that. So that should now start to look a bit more like a thermometer. Okay, yeah. So obviously that doesn't look like a thermometer, so that's not ideal. Let's make it look more like a thermometer. So with this being like a sort of a live coding part of the talk, specifically about like iterative software development, all errors you see are intentional, obviously. You see there, that's everything sort of interplaying together. So I actually got a lint warning there telling me I'd typed height twice, which helped me. There we go. So that now looks like a thermometer, so that's quite useful. So what we'll see now is when we change the temperature, the thermometer obviously doesn't get smaller because we've not written that code. So we should probably write that code. So let's set the height to be the temperature. There we go. Okay, so now we have a thermometer. Ta-da! Everyone should clap now. That's great. No, don't. So that's a thermometer. And that's kind of a boring thermometer. It's not very interesting. But the sort of thing we can start to do with a system like this is say, well, actually, that's not very useful to just see one at a time. So let's see more than one at once. So what would a thermometer look like if it's got a variety of different temperatures? So we say, oh, okay, right. And then we can start to spot some issues with our implementation so far. So thermometers generally don't get like bigger on the bottom, they stay the same height and fill up. So we'll make that change. So we'll say the height is now always, let's say, 100 pixels, and then the, so I actually need two elements now, I think, to make this work. So I need to set the style there. I think that's right. Yep. So that should look a bit more like. Okay, so we can see they are now all the same height, but the mercury is floating, which mercury doesn't. So what we need to do is then put the margin top to be, there we go, that's sort of right. Still not right, but I don't know why, it's fine. Yeah, and so if you kind of think about if we weren't using like a system like this where we could get some feedback, like what would it have taken for us to get these sorts of things? And in particular, this example, so we can see this one looks about right, but this one looks wrong. But I can only tell that because I can see three at once. And I don't normally see three at once, so this, you can start to see how this becomes quite useful. Can anyone spot why that's not right? No, actually I don't need this height here because the margin makes it work. Yeah, there we go, they're all the same heights. There we go. Yeah, so you can start to see how this sort of thing can become quite useful. So I actually built a much better looking thermometer than this in the actual talk. How am I doing for time? Oh, I'll see if I can do the next bit. So now we've got these, so we start to think, again, with our sort of unit testing type hat on, well, what if we put like different numbers in. Like, what if we put -10? What does that look like? Oh, that kind of looks all right. That'll work, yeah, okay. What if we put 200? So the thermometer is now, say, too hot. That's not great. But at least we can see it, and we can sort of see, okay, so what if we say, right, let's keep the temperature within a range. So let's say we're going to calculate the percentage, no, restrict. Yeah, so we're going to restrict our temperature to being between -50 and 200. Or 150, actually. Because, like, say if we had, like, an actual physical mercury thermometer, and it went up to 150 and it was hotter than that, then it would just be full, I think. Or maybe it would explode, I don't know. I don't know how to do the CSS animation for exploding, so I can't do that. So that has not worked. Oh, okay, so the problem is, yeah, my margin top's not bigger. So I've said the biggest is 150. So if I set that to 150 now, this should all sort of line up. There we go. But my negative one is still dropping off the bottom a bit, which is not ideal. So actually, if we think about, like, 0 shouldn't be 0. We want to sort of shift the scale a little bit, so we can modify that again. So if we do the temp equals, so if we figure out what is the percentage between sort of our bottom number and our top number, then that will give us a number. There we go. But we've changed these numbers as well as the size, so really that should be called a different variable. So let's do size, and then these two become size. So that should start to look a little bit better now. Yeah, there we go. But that's kind of weird because, like, the -10 is sort of here in the 10, so you can't really see where the 0 is. So this is the point where I try and, like, draw a line around the outside and try and make it look more like a thermometer. And in a previous iteration of the talk, I did try and do that live, and it went terribly. So hopefully I've got a blue Peter number here. So here's one I made earlier. So if I set that to 2, there we go. Okay, I'm in focus mode at the moment. So if I click on here, there we go. Okay, yep, so I'm actually starting to look like a thermometer now. So we can start to feel at 25. So if I look down, change this number to, say, like 10. Yeah, so we can see that 0 is about here, and this particular implementation goes down to, I think, about -30. So I set it to -35. This is Celsius, of course, because we're in England. And that's starting to look okay, but it's still pretty difficult to read. So I have hopefully managed to put some numbers on the side, and there we go. So now actually looks like a thermometer you might be able to read. I can probably bump the size up a notch. No, maybe not. Okay. And now we can say, yeah, all right, let's play around with this a bit more. So we can say 50. And I can sort of visually inspect that, yes, when I put this to 50, then it does line up with the 50 number. Now, trying to write a test for that sort of thing would be potentially quite difficult. I don't really know what sort of test I would write to say that, yes, visually, when my thermometer is 50 full, then the red bit lines up to the 50 mark on the side. That sounds like something that could be quite tricky to do. But my eyes are pretty good at this. Like, I can look at that and go, yes, that's correct. So as long as I remember to look at this page, then I can have confidence. And the sort of component approach that React promotes means that it's unlikely, certainly with this implementation, that any other component can mess with this particular component in a way that would break this sort of constraint. So that's quite nice. So let's increment our blue Peter number and have a look at step 3. So I've put the multiple possible states back in, and then we can start to see that, yeah, okay, so that's looking like a physical thermometer in a reasonable amount. That artifact there is to do with the browser zoom. It's not really there, because zoom is apparently awkward. But what we can spot here, now we're looking at our component in multiple different states at once, is that they're not particularly visually very distinct from each other. So yeah, if I go and read the dial, I can see which one's bigger or which one's hotter. And yeah, if I look closely, I can see the exact temperature, and I can get a rough idea of relative temperature from them. But I still have to go read it, figure out the number, and then in my head decide whether that's hot or cold. So let's introduce a bit more color to it. So what I've done here is I've taken a function which basically lets me interpolate the value across a range of colors. And now if I hit that, I should be able to see that the colder one goes a bit bluer, and then the hotter ones stay a bit redder. So that's quite nice. And I can play around with the colors if I want to. So I can say, let's make the blue a little bit colder. There we go. So it maybe feels a little cold. Well, I guess for -30, that's right. Or I can make it a bit more garish if I want. Say, let's try and interpolate those together. And yeah, It doesn't really look like mercury anymore. It's not starting to look like a thermometer as much. But maybe that's okay. Maybe nobody wants an old school thermometer. Maybe we want to really play around with I have no idea what it's going to look like. Oh, that's kind of all right, actually. I quite like that. Yeah. So these are the sort of things you can play around with interactively with the program, see what it looks like. And I think the key thing for this, so there's a few other similar systems I've seen that people have done talks about and experimented with, but showing a single component in multiple states at once is like the real, like, aha, this is useful to me moment. And I'm not necessarily saying you should use this tool, which I wrote, or any of the other tools that exist, but the general approach of, well, what if we just build our components in isolation and then add them to our application afterwards? Like, what sort of approaches does that enable? So what's next? Oh, okay, yeah. So this is still a little bit static. Like, it's on the page, we can see a bunch at once. So let's make it a little bit more interesting. Let's increment our Blue Peter number again. And we get, here's one I made earlier, number 4. So what I've done this time is I've added a form input into this page. So the form input code has been added to the card itself. You can see that here. So I've got an input in so I've defined my card. I've said I'm going to have a row of thermometers, and at the end of the row, under the last thermometer, I'm just going to throw an extra input, and then I've bound that to the state of a card. So what I can enable, for example, is so in this particular case, it's not very useful, but I can turn on inspection, and now my number should appear at the bottom of the card, so I can see that when this changes, my state changes over here, so I'm recording that information. And then we can see, yeah, okay, so as well as our predefined scenarios, we can interact with the page and see what it looks like in all the other scenarios. So for instance, you might notice that once the temperature goes above a certain point, it stays the same amount of red. Basically, it's just a multiplier in somewhere, just because it seemed weird to be like a slight hint of blue when it was like 70 degrees, which it still has. So yeah, we can start to get interactive and make these things. But we've kind of almost gone back to the original problem we had if we do this too much. So the original problem we had was we couldn't see what our component would be like unless we interacted with it. And then we said, okay, let's see it in loads of states. And now we said, okay, maybe you want to interact with it as well. So it's kind of useful that, yes, you can interact with it, but if you just make them interactive, then it's easy to forget, like, what are the interactions I'm supposed to do? So in this case, yeah, it's a text box, we just change the number. But what if there's like 3 or 4 different buttons, like, and if you press them in a certain order, it does something? Like, do I need to remember that? So when I'm using this page, I mean, I could put like a little hint sheet at the bottom. I'd say like, okay, don't forget to click on the thing. And then if like future me coming back to this can read this thing and say, oh yeah, don't forget to click on the thing, I'll click on the thing. Clicking on the thing doesn't do anything. But it's fine. So there is another thing. So implement our Blue Peter again. So this time, in case we forget to interact, we can sort of pre-script an animation. We can say, okay, on a timer, do this. And then because timers are really annoying, if they all play at once on a big screen, then it's off by default. So I can turn on the ticking. And now this particular component over here, like just every few hundred milliseconds, just ticks this in. So now I don't need to remember what the interaction is. I can pre-arrange the interaction on the page. So my current project at work, which I don't think I can show, so I probably won't, but it's like an interactive canvas. And what I've done is I've written like a little DSL in sort of the layers on top of this card system to fire in a series of mouse events. So it says, okay, what happens if I click here and then move the mouse over here and then click here and then move the mouse over here and click here? And then for a different component, I've pre-scripted a bunch of scenarios, and then when I make a change, I can see the reaction on all of those at the same time. So that's a little jerky, actually. So now that I can see it moving, I've decided, actually, let's make it a bit smoother, and we'll apply a CSS animation. And then once I save, there we go. So now it actually feels like, ooh, it's getting warmer. It's good. Right. And then obviously we can check that, yes, what does that do the right thing when we're going over here? And actually maybe it's kind of annoying that it moves slower when it's more, so we can play around with it a bit more. Or we could have a second animation next to it that did another thing. And the code to do that animation is really tiny. So I've got like a callback down here that says what to do when you tick. I've got my initial state. I've got an interval, whether or not to autoplay. And then the actual code for the main body of the component is pretty much the same. Yeah. So that's the sort of the thermometer. Ta-da. So when I first did this talk, people said, okay, well, this is working really well with React. Like, does it only work well with React? And the answer is sort of yes. So when you use React or a system like it, you build user interface components that generally take external data as like well-defined inputs and render it. Given particular data, here's what my page will look like. And this general approach to building components or templates or whatever lends itself really, really well to hot reloading, because I've separated my data from my behavior. So I can change my behavior but keep my data the same and then see the results like this. But as long as you do actually sort of separate your data and your behavior in some sort of way, then you can still do useful things. So here I've got a moustache template over here on the left, and then over here on the right. So this is the HTML that powers this template, and I can definitely say, okay, I'm just going to change this HTML, I'm going to hit save, and then that's going to have an effect on the left-hand side. And basically, the way to do things like this, so in this case, in sort of this imaginary scenario, my real application doesn't use React, but when I plug it into a dev cards type system, then it does use React. Moustache. So what I've done is I've basically just defined a function that can take a template and some data, and then that in itself then does a little bit of React to just glue the two things together. But I can use this same function for any interactive components that's using whatever, and that all just works. So the main difference between doing an actual React component and using this approach is that when I do change the state, I have to throw away all of my like in progress part of the component. So when I change this file here, I end up like re-rendering the whole like DOM element. It just gets thrown away and put back. So I lose that nice thing where I knew what the exact value was. So you could build that sort of thing on top of it. But generally, a system like React or a system like it is sort of the best way to get the benefits of something like this. Yeah, so that was confident user interface programming. I hope you'll agree. And yeah, that was me. So that went a little faster than I thought it would, but means I've got time for questions, I guess. Yes, at the back.
Hi. I was wondering how you then, if you've got a project that is sort of running in production, you've got lots of your components already in an existing project, and you work to try and, rather than developing your own components in isolation with them, how is there ways to kind of use this with existing, like porting models from other projects and things like that?
Yeah, so if to try and summarize the question, it's like, if you're building these components in isolation, how do you then put them into the application or share them across multiple applications?
Or once they're in another application, how does this system tackle?
Okay, and how do you take them out of an application and put them into a system like this? Okay, yeah. So this particular demo doesn't, I think, but in the cases where I've used this in an actual app, generally I've got the exact same Webpack build config, and there's just an additional entry point for the dev card, so it's in the same software project. It's just a subfolder which contains the cards, and then so in this case I've written the components in line, but in practice I would usually import the component from its real location and then use it in this case. So it's sort of in the same way you might have a subfolder called tests, I also have a subfolder called Devboard, and then all this stuff goes in there. Does that answer the question? Yeah. Okay. Cool. And then you can also do things like, so if you're thinking about what components benefit most from this, so I've got an example here of doing, say, Bootstrap. So you can sort of see how this is similar-ish to having like a visual style guide, only it's also your scratch board for when you're actually making changes to that. And you can say, okay, yeah, here's, so for example, say progress bars is a nice demo of this sort of thing using. So if you're, say, you've got like a sub-team in your company that builds the user interface components for the rest of the company, then this sort of thing might be really powerful for that. Yes?
Is your GitHub the same as your Twitter?
Is my GitHub the same as my Twitter? No, it's not, and it's really annoying. So my, yeah, so if you Google for Glen Mailer, there aren't many of them, and none of the others are programmers. But basically, yeah, so my GitHub is Glenjamin, which is like Benjamin, but with Glen. Yeah, so I will try and put together, so I don't actually have any slides I can share really, but I will try and put together a little like, summary of what I said today and share that with the Code Mesh organisers.
I'm guessing this Devboard is up on there?
Yep, so Devboard is on GitHub, and it is installable through NPM, and the docs are sort of there. So I've done the talk a few times, and people are like, yeah, that's great, and then I don't know if anyone's ever used it. But so, like I said before, I'm not particularly precious about using my implementation, but I'd really like more people to use this idea. and especially in other languages as well. Any other questions? No? Okay, that feels like we might be first for lunch then.